called Darwinian and Neo-Darwinian evolution, meaning that essentially what it means is that as a result of random mutations of the DNA, in other words, the theory says we have this DNA, which is the code of life. It codes for the proteins. It's a string of letters A, T, G, and C, and they have a normal sequence for the organism or for the individual in the organism. And then if one of the base pairs, the A, T, G, or C, gets mutated, i.e. changed because of random factors or toxic factors or just so happens, that's like random factors, then you have a change in the gene and you have a change in the protein that's coded for by that gene. And then that protein creates a different phenotype or expression of the individual, and that individual may be have a better survival advantage, and therefore they reproduce more, and then you get a new changed organism which is more evolved than the previous ones as a result of this process called natural selection. And so that's their theory as to how all of the things that we see, all of the living beings that we see, bacteria, plants, fungi, animals, humans, that's how we all evolved one step after another of these genetic mutations, basically random, and then some of them create a adaptive advantage called natural selection. They get selected for, they reproduce better, and create a new organism. So the question then is, where's the proof of that? And obviously, the proof should be you take one organism and you transform it step by step into another organism, right? Then you would have proven this through a process of maybe induced mutations in the first organism. So you can speed up the process, you can induce mutations, which would give you more raw material to select from. Then you get new organisms, select for that they get selected for because they have a reproductive advantage. One thing leads to another, one step leads to another, and then you get the new organism. So researchers at MIT, here's the article, are trying to do this process and recreate woolly mammoths, the animals on land who are said to be the largest land mammals, I believe, that have ever lived. And they're doing this at MIT using these genetic selection, starting with mice, one step after another, creating the woolly mammoth. And so I thought I would show you a picture of how far they've gotten so far. So here's the woolly mammoth. I don't think this is a picture. I think this is a computer-generated image, but never mind. And so they start with a mouse, and they've gotten pretty far into it. So here you go. You can then see a picture of the mouse who's well on his way to becoming a woolly mammoth. And there he is. And they said in the paper that it should take not so long. They're estimating, I think, 112,364,284 years, 6 months, and 4 days of this process of induced mutations and then natural selection. So that would put it on a Tuesday, which is good, because then they'll be able to keep track of the woolly mammoth for the rest of the week before they go away on for the weekend. So as you can see, they've almost got it, and then at the end of it, they're going to try to mate the woolly mammoth and the mouse. They're going to keep this mouse going in its current form. They're going to try to mate it and create a hybrid mouse mammoth, And I can tell you, I don't want to be around when the mating session of the mouse and the woolly mammoth, especially if I was the mouse. So that's where we stand with evolution. And I don't know if I'll be around in 12 million years, but good luck to them. And I'm sure they can use all the federal funding they can get to continue this exciting project.